Hello students, welcome to the lecture on database management system, and after the lecture we will be able to learn the following objectives: explain data versus information, understand about data dictionary, define the DBMS versus file system, describe the concept of database administration DBA, explain the DBMS architecture and data independence, define database schema versus database instance, understand the data mapping and database models. Let's start with a brief introduction to the database management system. We tend to think of a database as information stored on a computer that we can access and alter, but the database is just information. It is a bit like a filing cabinet full of files in an office. Without procedures in place, we wouldn't know where to put the files in order to retrieve them when we wanted them again. Without the forms, each file would be a random collection of information, and even when we found it, we would not be able to make sense of it or compare it to other files easily. The database management system provides ways to organize, store, retrieve, and interact with the data in the database. It consists of a modeling language used to define the database schema or structure. Common database structures are hierarchical, network, relational, and object-based. Models differ in how they connect related information. The most widely used, particularly in web applications, is the relational database model, a database engine that manages the database structure and optimizes the storage of data, whether that is fields, records, files, or objects, for a balance between quick retrieval and efficient use of space. A database query language such as SQL that enables developers to write programs that extract data from the database, present it to the users, and save and store changes. A transaction mechanism that validates data entered against allowed types before storing it, and also ensures multiple users cannot update the same information simultaneously, potentially corrupting the data.
Welcome to this tutorial series on SQL and database. But before we learn about database, let's understand what is data. In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. are some data related to you. A picture, image, file, PDF, etc. can all be considered data. Now, what is a database? We already know what data is, but this data could be random. A database is a systematic collection of data. Since the data in a database is organized, it makes data management easy. What is a database management system? DBMS. Database Management System, or DBMS, is a collection of programs which enables its users to access a database, manipulate data, and help in the representation of data. It also helps control access to the database by various users. Let's discuss a few examples. An online telephone directory would definitely use Database Management System to store data pertaining to people, phone numbers, and other contact details. Your electricity service provider is obviously using a DBMS to manage billing, client-related issues, to handle fault data, etc. Let's consider the Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisements, and a lot more. We can provide countless numbers of examples for usage of DBMS. Database management systems are not a new concept, and as such had been first implemented in the 1960s. Charles Bachman's Integrated Data Store, or IDS, is said to be the first DBMS in history. With time, database technologies evolved a lot, while usage and expected functionalities of databases have been increased immensely. Types of DBMS. Let's see how the DBMS family evolved with time. The following diagram shows the evolution of DBMS categories. There are 4 major types of DBMS. Let's look into them in detail. Hierarchical. This type of DBMS employs the parent-child relationship of storing data. This type of DBMS is rarely used nowadays. Its structure is like a tree with nodes representing records and branches representing fields. The Windows registry used in Windows XP is an example of a hierarchical database. Configuration settings are stored as tree structures with nodes. Network DBMS. This type of DBMS supports many-to-many relationships. This usually results in complex database structures. RDM Server is an example of a database management system that implements the network model. Relational DBMS. This type of DBMS defines database relationships in forms of tables, also known as relations. Unlike the network DBMS, RDBMS does not support many-to-many relationships. Relational DBMS usually have predefined data types that they can support. This is the most popular DBMS type in the market. Examples of relational database management systems include MySQL, Oracle, and Microsoft SQL Server. Object-oriented relational DBMS. This type supports storage of new data types. The data to be stored is in the form of objects. The objects to be stored in the database have attributes, for example, gender or age, and methods that define what to do with the data. PostgreSQL is an example of object-oriented relational DBMS. So what is SQL? Structured Query Language, SQL, pronounced as SQL or sometimes as SQL, is actually the standard language for dealing with relational databases. SQL can be effectively used to insert, search, update, and delete database records. That doesn't mean SQL cannot do things beyond that. In fact, it helps in optimizing and maintenance of databases and much more. Relational databases like MySQL, Oracle, MS SQL, Sybase, etc. use SQL. SQL syntaxes used in these databases are almost similar, except the fact that some databases use different syntaxes and even proprietary SQL syntaxes. An example of an SQL statement: select star from members where age is greater than 30. DBMS stands for Database Management System. We have 4 major types of DBMSs called hierarchical, network, relational, and object-oriented. The most widely used DBMS is the relational model that saves data in table formats. It uses SQL as the standard query language. SQL is the standard language used to query a database. The database approach has many advantages when it comes to storing data compared to the traditional flat file-based systems.
Let's now discuss about data versus information. Data and information are interrelated. Data usually refers to raw data or unprocessed data. It is the basic form of data, data that has not been analyzed or processed in any manner. Once the data is analyzed, it is considered as information. Information is knowledge communicated or received concerning a particular fact or circumstance. Information is a sequence of symbols that can be interpreted as a message. It provides knowledge or insight about a certain matter. In fact, they are often mistakenly used interchangeably. Data is considered to be raw data. It represents values of qualitative or quantitative variables belonging to a set of items. It may be in the form of numbers, letters, or a set of characters. It is often collected via measurements. In data computing or data processing, data is represented by inner structures such as tabular data, data tree, a data graph, etc. Basically, information is a message that is being conveyed, whereas data are plain facts. Once the data is processed, organized, structured, or presented in a given context, it can become useful. Then data will become information, knowledge. Data in itself is fairly useless until it is interpreted or processed to get meaning, to get information. In computing, it can be said that data is the computer's language. It is the output that the computer gives us, whereas information is how we interpret or translate to the language or data. It is the human representation of data. Some differences between data and information. Data is used as an input for the computer system. Information is the output of data. Data is unprocessed fact figures. Information is processed data. Data does not depend on information. Information depends on data. Data is not specific. Information is specific. Data is a single unit, whereas a group of data which carries news or meanings is called information. Data does not carry a meaning. Information must carry a logical meaning. Data is the raw material. Information is the product. We shall now talk about data dictionary. The data dictionary or data repository or system catalog is an important part of the DBMS. It contains data about data or metadata. It means that it contains the actual database descriptions used by the DBMS. In most DBMSs, the data dictionary is active and integrated. It means that the DBMS checks the data dictionary every time the database is accessed. The data dictionary contains the following information: logical structure of database, schemas, mappings and constraints, description about applications, programs, descriptions of record types, data item types and data aggregates in the database, description about physical database design such as storage, structures, access paths, etc., descriptions about users of DBMS and their access rights, active and passive data dictionaries. An active data dictionary, also called integrated data dictionary, is managed automatically by the database management software. Since active data dictionaries are maintained by the system itself, they are always consistent with the current structure and the definition of the database. The passive data dictionary, also called non-integrated data dictionary, is the one that is used only for documentation purposes. Data about fields, files and people and so on in the data processing environment are entered into the dictionary and cross-referenced. Passive dictionary is simply a self-contained application and a set of files is used for documenting the data processing environment. Let us now learn about the DBMS versus the file system. Computer-based data processing systems were initially used for scientific and engineering calculations. With increased complexity of business requirements, gradually they were introduced into the business applications. The manual method of filing systems of an organization, such as to hold all internal and external correspondence relating to a project or an activity, client, task, product, customer or employee, was maintaining different manual folders. Database Management System or DBMS. A group of collected data which is called database is accessed by special software and purpose-built hardware called DBMS. Main purpose of DBMS is to make the necessary connection, store and delete data from the database. We have tried to list some advantages and disadvantages of DBMS. The goals of the database management system can be summarized as follows: a user-accessible catalog, transaction support, concurrency control services or multi-user update functionality, recovery services or damaged database must be returned to a consistent state, authorization services or security, support for data communication, integrity services, that is constraints, services to promote data independence, utility services, that is importing, monitoring, performance, record deletion, etc. We shall now learn what a database administrator is. A database administrator or a DBA directs or performs all activities that are related to maintaining a successful database environment. Responsibilities include designing, implementing and maintaining the database system, establishing policies and procedures pertaining to the management, security, maintenance and the use of the database management system, and training employees in database management and use. A DBA is expected to stay abreast of emerging technologies and new design approaches. A DBA is usually expected to have experience with one or more of the major database management products such as Structured Query Language, SAP, and Oracle-based database management software. The DBA administrators the three-level of database and consultation with the overall user community, sets up the definition of the global view of the various users and applications, and is responsible for the definition and implementation of the internal level, including the storage structure and access methods to be used for the optimum performance of the DBMS. The DBA is responsible for granting permission to the users of the database and stores the profile of each user in the database. It is the DBA's job to decide exactly what information is to be held in the database, in other words, to identify the entities of interest to the enterprise and to identify the information to be recorded about those entities. Having done this, the DBA must then define the content of the database by writing the conceptual schema. The DBA must also decide how the data is to be represented in the database and must specify the representation by writing the storage structure definition. In addition, the associated mapping between storage structure definition and the conceptual schema must also be specified. It is the business of the DBA to liaison with users to ensure that the data they require is available and to write the necessary external schemas. In addition, the mapping between any given external schema and the conceptual schema must also be specified. In practice, the external DDL will probably include the means for specifying the mapping, but the schema and the mapping should be clearly distinguishable. Authorization checks and validation procedures may be considered as logical extensions of the conceptual schema. The conceptual DDL will include facilities for specifying such checks and procedures. Let us now understand the DBMS architecture and the data independence. The DBMS architecture describes how data in the database is viewed by the users. It is not concerned with how the data is handled and processed by the DBMS. The database users are provided with an abstract view of the data by hiding certain details of how data is physically stored. This enables the users to manipulate the data without worrying about where it is located or how it is actually stored. In this architecture, the overall database description can be defined at three levels, namely internal, conceptual and external levels, and thus named three-level DBMS architecture. The three levels are: internal level, it is the lowest level of data abstraction that deals with the physical representation of the database on the computer and thus is also known as physical level. It describes how the data is physically stored and organized on the storage medium. Conceptual level. This level of abstraction deals with the logical structure of the entire database and thus is also known as logical level. It describes what data is stored in the database, the relationships among the data and complete view of the user's requirements without any concern for the physical implementation. External level, it is the highest level of abstraction that deals with the user's view of the database and thus is also known as view level. In general, most of the users and application programs do not require the entire data stored in the database. The external level describes a part of the database for a particular group of users. Let's now discuss about the database schema versus database instance. While working with any data model, it is necessary to distinguish between the overall design or the description of the database schema, and the database itself. As discussed, the overall design or the description of the database is known as database schema or simply schema. The database schema is also known as an intention of the database and is specified while designing the database. The data in the database at a particular point of time is known as database instance or database state or snapshot. The database state is also called an extension of the schema. The various states of the databases are empty state. When a new database is defined, only its schema is specified. At this point, the database is said to be in an empty state as it contains no data. The initial stage. When the database is loaded with data for the first time, it is said to be in its initial stage. Current state, the data in the database is updated frequently. Thus, at any point of time, the database is said to be in the current state. The DBMS is responsible to check whether the database state is valid state. Thus, each time the database is updated, DBMS ensures that the database remains in the valid state. The DBMS refers to DBMS catalog where the metadata is stored in order to check whether the database state satisfies the structure and the constraints specified in the schema. We will now talk about data mapping. Data mapping is the process by which two distinct data models are created and a link between these models is defined. Data models can include either metadata and atomic unit of data with a precise meaning in regards to semantics and telecommunications. The system uses the atomic unit system to measure the properties of electricity which contain the information. Data mapping is most readily used in software engineering to describe the best way to access or represent some form of information. It works as an abstract model to determine relationships within a certain domain of interest. This is the fundamental first step in establishing data integration of a particular domain. The main uses for data mapping include a wide variety of platforms. Data transformation is used to mediate the relationship between an initial data source and the destination in which that data is used. It is useful in identifying parts of data lineage analysis, the way in which data flows from one sector of information to another. The mapping is also integral in discovering hidden information and sensitive data such as social security numbers when hidden within a different identification format. In regards to the basic mapping techniques of a data element, a number of specific formula considerations need to be addressed. The data element itself needs to identify and named, a clear definition of the data needs to be determined, and representation of the values are enumerated. In some terms, the identifiers are represented in the form of a database. Standard structures are built with basic units of information such as names, addresses, or ages. Let us now discuss the database models. The main objective of database system is to highlight only the essential features and to hide the storage and data organization details from the user. This is known as data abstraction. A database model provides the necessary means to achieve data abstraction. A database model, or simply a data model, is an abstract model that describes how the data is represented and used. A data model consists of a set of data structures and conceptual tools that is used to describe the structure, the data types, relationships, and constraints of a database. Conceptual data model. Conceptual data model describes the information used by an organization in a way that is independent of any implementation level, issues, and details. The main advantage of conceptual data model is that it is independent of implementation details and hence can be understood even by the end users having non-technical background. The most popular conceptual data model, that is entity relationship ER model. Representational data model. The representational or implementation data models hide some data storage details from the users, however, can be implemented directly on a computer system. Representational data models are used most frequently in all traditional commercial DBMS. The various representational data models are hierarchical data model. The hierarchical data model is the oldest type of data model developed by IBM in 1968. This data model organizes the data in a tree-like structure in which each child node, as known as dependents, can have only one parent node. Network data model. In the network data model, the data is also represented by a collection of records and relationships among data are represented by links. However, the link in a network data model represents an association between precisely two records. Like hierarchical data model, each record of a particular record type represents a node. However, unlike hierarchical data model, all the nodes are linked to each other without any hierarchy. Physical data model. Physical data model describes the data in terms of a collection of files, indices and other storage structures such as record formats, record ordering and access paths. This model specifies how the database will be executed in a particular DBMS software such as Oracle, Sybase, etc. by taking into account the facilities and the constraints of a given database management system. It also describes how the data is stored on disk and what access methods are available to it. Now in the end, let us summarize what we have learned in this lecture. The object-oriented data model extends the concept of object-oriented programming language to persistence, versioning, concurrency control, data recovery, security and other database capabilities. The relationship between the two tables is implemented through a common attribute in the tables and not by physical links or pointers. The main advantage of network data model is that a parent node can have many child nodes and a child can also have many parent nodes. The main advantage of network data model is that the parent node can have many child nodes and a child can also have many parent nodes. Data mapping is the process by which two distinct data models are created and a link between these models is defined.